The problem statement I have selected is sustainability and wellness. I have named the application Svasthya, which means to be aware of oneself. Before we go further, let me introduce myself. Hello, I'm Abhilash. I'm currently in my final year pursuing Master of Computer Applications from Amrita Vishwavidyapita, Amritapuri campus. I have also worked as a part-time full-stack developer in a private company called Hicks. I mainly work with the React, Firebase and Mern stack. I have also done an internship with AIMS Cochin. The project was on detecting autonomic dysfunctions from ECG and respiratory signals. It was a pilot study and the first of its kind. During the internship, I go to work with some of the best doctors in India, and we also wrote a journal article which is submitted to International Journal of Artificial Intelligence. My experience with full stack development, healthcare and machine learning is why I have selected this topic. So coming to the problem statement, a company has already provided wearables to the employees, and my objective is to develop applications to monitor the health of employees individually and as a group. Moving on to the task part, the first would be to deploy an open API or IoT device. Secondly, develop mobile and web application for monitoring purposes. Third would be developing prediction models for diseases, followed by a module on stress management. Then finally, functionalities for chatbot and email automation. Some considerations to be made are Fitbit or Google Fit integration, real-time sync, encryption, and some kind of mechanism to uniquely identify a device. On the front end, I have used a React framework called React Admin, which is built on top of Material UI components. On the back end, have a Flask REST API server with prediction models and OpenAPI as endpoints, and then an SMTP server for mailing. Some other major libraries I am using are sklearn for machine learning algorithms and Crypto for encryptions. Fitbit API, I am using Firestore as a database along with other Firebase services such as auth and storage. As for IDE, I have used Android Studio and Visual Studio Code. We can divide the project into 5 sections. We have the wearable, which is connected to the Android device. Then we have the single user mobile application and multiple user web administration. The Firebase stack, which handles the authentication, stores medical records and handles the medical data. Then we have the SMTP server, which sends updates on users' health every day. A REST API, which sends the predictions to the user. Machine learning models such as KNN, SVM and logistic regression have been used for disease prediction. The models are trained on data curated from normal and abnormal range of values. I have also experimented with UCI dataset for coronary heart disease. Then here diabetes uses a multi-label classifier to classify into normal, pre-diabetic and diabetic. Also the models take into consideration if the user is running or just had a meal during the predictions. I have kept a separate notebook for machine learning in my GitHub repository. Please feel free to go through it. Finally, a Fitbit API is present to collect and display the information from Fitbit servers. The project includes an Android app for a single user and a website to manage multiple users. This is the use case diagram for a single user. To use the app, the user has to register and log in. After login, the user is sent to home screen where it will check if it's connected to the Open API or not. If it is connected, then the Open API developed on the Python Flask framework randomly generates the values associated with diabetes, asthma and other diseases. The data is sent to the user's phone and is updated every 30 seconds. The user can choose to sync the device with the wearable at any point in time. Data from the device is sent to the backend REST API where the data is run through multiple machine learning models. In case of an anomaly, an email will be sent to the user as an alert. The predictions are then sent to the mobile application where the data and predictions are displayed and added to the Firebase collection for health data. Additionally, the users can manually enter the data and get predictions. Users can also upload documents and view them at a later point in time. The predictions could be viewed at user discretion. A special module on stress has also been built. The module features stress detection and management. Stress detection involves using the frequency domain metric LFHF ratio of HRV, heart rate variability, extracted from ECG, which is often used as a biological marker to identify stress and anxiety disorders. Stress management includes 5-minute meditation, breathing exercises, games, and a pedometer or step tracker, which uses accelerometer to measure steps for taking. They are the small box. A chatbot has been integrated into the app for getting the user's health status and medical records. I have used a similar system to intent and entity recognition to identify what the user is saying. This can be further improved by using APIs like bit.ai or API.ai, which was supported by Google, for much better intent entity recognition. Additionally, Fitbit API has also been integrated into the app, which can be used to get the data. Fitbit has its own authentication process. Then the user can also log out if he wishes to. To ensure security, user authentication is required on both the client and admin side. AES encryption has been used for data transmissions. Additionally, Firebase security rules has also been applied. The device ID is also collected from the user's mobile device to uniquely identify the device. The admin website has its own authentication process. After authentication, the admin can view the health status of the employees, health records uploaded, manual entries made by the user, view user informations. The admin can also use the search functionality based on username. An SMP server is also configured to send an update on the user's health every day. This is a splash screen of the app. I had designed the app and its logos in Paint 3D. Let's have a look at the demo of the application. Let me just launch the app. This is a splash screen. Now we have arrived at the landing screen. In order to proceed further, we need to create an account. I have already done that, so let's go to the sign in page. When registering, you have to make sure that the account is valid. Only then would you be receiving the email updates. It may take a second to load. This is because the data has to be fetched from the Open API. Then it is sent to the Flask server for where it will be analyzed and predictions will be made, which is then displayed here. It also sends a summary or status report back stating what is wrong. When a certain parameter is high, an email is automatically sent to the user. Then we have the chatbot. I'll show the chatbot in a moment. Next section is the measures, shows the different sensor readings. So have blood sugar level which is high, so the patient will be having diabetes, yes. And we have some more parameters in the red. Okay, it also considers whether the person has eaten food or is he running while making predictions. Here LFHF ratio was introduced to see if the patient is stressed. LFHF ratio is commonly used as a biological marker for seeing if the person is suffering from anxiety or stress related disorders. Now moving on to the manual part. So I can upload a file here. Oh, I have to enter the name first, otherwise it would be difficult to get back to. Okay, the upload is successfully completed and it is stored into the storage. Okay, now I'll just enter some values and show how the prediction model is working. Okay, so I have sent this to the Flask server and it is giving me back the prediction and what is the status of the patient. Okay, and it is just described in the above section. As you can see, most of it is yes because I entered very high values. LFHF ratio is no because when LFHF ratio is actually the variability in heart rate. Since it is very high over here, it indicates that the person is alright. Although this is a bit too much, usually it's around 1 to 2.5. I can also view the entries that I have made, files that I uploaded. Then we have the relax section, which constitutes of the meditation, breathing techniques, then a game which is the Chrome Dino game, and finally a pedometer to just walk and relax.
Hey there, and thanks for gifting yourself these next few minutes. It's important to remember that you're a priority, and allowing yourself even just a few short minutes of intentional reflection can really have a positive impact on the rest of your day. So let's use these next few minutes to come back to center and set an intention.
Okay, on to the next one.
Mindful breathing. Close your eyes and rest your hands on your knees. Bring your...
So this is a breathing technique to relax the person. Then next you have the Dino game, which is my personal favorite. We all must have played this game at some point when the Wi-Fi was down. So let's have a look. It's pretty much the same. Guess I could spend a lot of time just playing this. There are also other variations. I could select the Batman as my character. As you can see, this is quite the time passer. Yeah, okay. Next we have the pedometer. So this makes use of the built-in accelerometer to calculate steps. Let me just take quick steps. As you can see, the values are getting updated. So a quick walk can easily relax you. Then going back, the Fitbit API. So I need to sign in here. This will launch a web view where we will be entering our, where we will be authenticating ourselves. Yes, authentication is successful, so I'm able to get my personal data from Fitbit, and I have just displayed it over here, my height, my age, the number of steps I usually walk. I don't really use Fitbit, that's why it's 0. Then my stride length, walking and running. There are also many other parameters which I have not put here. I have just kept some. Then I guess I have to show the chatbot. I can look at previous files. Yes, current status of the patient, user. Yeah, it's giving us its entire details. Okay, next I'll just show the emails which are being received. So this is the daily user health report. So it just shows what are the conditions and a status summary. Then if a parameter is too high, the application will automatically send a mail saying that your, in this case, blood sugar levels are too high, oxygen saturation levels are running low. I have temporarily disabled email because my account keeps getting banned because of multiple mails from the same ID. The website is built on top of React Admin and Material UI. Let's see a demo of the application. Let's have a look at the website where we can manage multiple users. Let me just log myself in. Okay, this is the status page. It shows the health status of all the users. You can also search here. Okay, and now the manual entries. These are all the manual entries that I have made. You can also search check if not available. Yes. Okay, I can also sort. adjust the number of rows in the page duration. I can also export this. It has downloaded below. Then next we have the records. You can sort it according to the date, time. We have the URLs, number of records we want per page. Then export if we want to. Then we have the user details. The past 2 months has been a great learning experience. I have tried to implement almost all of the features described in the problem statement. The module on stress detection can be further improved by training it with more features from ECT signal. The application development part has been a great experience to me, especially coming up with new designs and logos. I sincerely appreciate that I have had this opportunity to take part in this hackathon by TCS. If anyone would like more information or has questions, please feel free to contact me. Thank you.